Hello, my lovely FRM friends, and welcome back to another reading with me, Martin Stoyanov. Today, we're going to be looking at hypothesis testing, so let's get started. Okay, so with hypothesis testing, and of course, that is one of those notorious topics in statistics for this type of exams where, people will be a little bit extra worried. So we're going to take our time here, but it's really not as bad as it looks the first time you look at that topic. But with hypothesis testing, we are going to be setting a couple of hypotheses. So our null hypothesis, denoted as H0, will be the hypothesis that our researcher essentially wants to reject or wants to disprove. And the easiest ever way to spot the null hypothesis in a problem is that it must contain the equal sign. So an example of a null hypothesis could be H0 is mu equals to 0, right? We know that this is a null hypothesis because it contains the equal sign. So does the status quo, the kind of the base case hypothesis in our case is that the mean return is 0. We obviously likely want to reject this because we don't want to have a trading strategy with a mean return of 0. So we will aim to reject that, and if we are successful at rejecting it, we shall then conclude that the alternative hypothesis must be true. Now, of course, if you reverse the argument, the alternative hypothesis must be the hypothesis that the researcher would like to conclude, and it's also the one that must contain all remaining states of the world. So because our null said the mean is equal to 0, then the alternative must say that the mean is different from 0. And this is an example of a two-tailed test because we are able to reject the null if we find a sample that is significantly to the left in the left tail of the distribution or significantly to the right in the right tail of the distribution. So when we are talking about the significance of the test, we will be splitting that across two tails. Now that's, as I said, two tails. And now let's look at one tail example. Well, with the one tail example, the null could perhaps say that the mean is less than or equal to 0. So in this case, what we want to reject is the fact that the return is negative or 0. And of course, the remaining state of the world here is that the mean is greater than 0, which of course is desirable. Now, of course, we can only reject the null if we find a sample statistic that is located deep inside the right tail of the distribution. So therefore, we've got a one-tailed situation, and therefore our significance of the test must be all contained in the right tail. Now, we spoke at length about the central limit theorem, and essentially we concluded that when we were to repeatedly take samples from an underlying distribution, the sample mean, in other words, the X bar, will unbiasedly predict the population mean. However, the volatility of the resulting sampling distribution will no longer be the volatility of the underlying distribution, which was sigma, but it would become the standard error. And the standard error is nothing more than the standard deviation of the sample mean, which is calculated as the standard deviation of the underlying population divided by the square root of the sample size. So we can see here that as the sample size grows larger and larger, the volatility of the sample mean will get narrower and narrower around the true population mean. Now, this formula can be calculated in one of two ways.